Firstly, starting with this, we are going to, start with global system for mobile communication. So basically, what is GSM? GSM is nothing but the second generation cellular standard. Right. So this is second generation cellular standard we all know, and this was developed to cater voice service and data service as well, so that we can use the digital modulation system. So basically, this GSM is the world's first cellular system, to specify digital modulation network level architecture and services, and it has become world's most popular 2G technology. So basically, what happened that it was, I mean, before GSM, some European countries use different cellular standards, but in case of, in 1991, basically this GSM was introduced in the European market, and by the end of the 1993, several non-European countries in South America, Australia, and Asia had adopted this GSM. So this is what basically the basic of, you can say, the basic introduction of the GSM. So what are the services that basically this GSM are going to offer? This usually offers three kinds of services. One is teleservices, which includes the mobile emergency calling, the fax, all the things. There are data services as well. Because sometimes it may happen that basically, this telephone services, which is including this, this fax, this video text and teletext are also supported in GSM. But what happens that whenever we are dealing with the data services of GSM, that includes all the voicemails. And what happens, these data services or the bearer services that uses only lower three layers of OSI models. Have you ever gone through the network layers? Then you can see that they are these particular data services uses only the lower three layers of OSI model, and supported services include the packet switch data services, which is offering 300 bps to 9.6 kbps kind of data rates. And the third services which GSM offers, that is all the incoming and outgoing calls, which is the supplementary services. Those all incoming and outgoing calls, this include call diversion, this include call wait, caller line identification, user group, short messaging service, which we often term as SMS service, etc. So using this SMS, GSM subscribers at that point of time could transmit numeric pages, which consist up to 160 characters and or like that. And SMS can provide a cell broadcast of up to 15 93 characters of strings, and obviously some kind of advisory application, some kind of safety protocols, and also these kind of services that comes under these supplementary services. Now, what are the advantages of GSM? So automatically, if GSM was so popular in those days, this is one of the most popular 2G service. So automatically, GSM should offer a number of advantages. So what are those? Those advantages come into these five categories. We can segregate that. In terms of communication, there are mobiles, there are wireless communication. This GSM supports voice and data services, as we have just mentioned. Then obviously there is a kind of mobility, like international access, the chip card enable use, and some kind of that also provides some kind of access points of different providers. And obviously there is a, I mean, there is a worldwide connectivity, right? There is one number and all the network handles every location. This bears highest capacity, I mean a very good capacity. It has a better frequency efficiency. It is using smaller cells because what we have already learned in case of cellular concept, this is just, this GSM service enhances those cellular concept for quite a higher pitch, and more customers per cell usage is enhanced. High transmission quality because audio quality becomes better, reliability for wireless becomes better, uninterrupted phone calls at higher speeds. That means there the I mean the lesser chances of handoffs are coming basically from cars, from trains, from the mobile vehicles. So basically those are the higher highest points for which GSM becomes so popular. These are the very advantages or merits, we can say, for GSM. Now coming to the GSM architecture. So whenever we are going to deal with GSM architecture, this is one most important area of GSM. So what we used to see from this particular figure, we can see that we can segregate three distinct phases for this particular GSM architecture. So what we have one mobile station at the very left point, at the very left hand slide. And obviously this mobile station, you can see, is connected with the BTS. I'm coming to the all the particular nomenclature, then BSCs. And here we have the second segment, which is called network switching subsystem. This is base station subsystem, this is public network. Now coming to the whole architecture, what we are going to follow, that is, sometimes it may happen that GSM consists of the following three major interconnected subsystems, right? So these subsystems, you can see, those interact between themselves and with the users with the network. This is the mobile station which we are talking about. So what we have here, that is, one is our base station subsystem, which is the this part. And this base station subsystem has a certain base transceiver system as well. So this BTS base transceiver stations are the major highlight portion of the base station subsystem. Apart from this base station subsystem, we have network and switching subsystem and the operation support subsystem, you can see, OS, and which we have a connection, strong connection with the public networks as well. So basically what happens is mobile station, which we usually have drawn here in at the most left hand side of the slide, this is also considered as a part of this base station subsystem. So what happens that this base station subsystem, which is also known as the radio subsystem somewhere, this provides and manages radio transmission paths between this mobile station and this mobile switching center, but obviously via this base transceiver station and obviously this particular units. Now what happens that this is a kind of subsystem which offers a kind of hand of management means this subsystem is responsible to avoid all the unin all kind of unwanted interruption between the call whenever a particular mobile station is moving from one cell to another cell. So what happens is BSS consists of many base switching center, and what happens, these switching centers connect to a single mobile switching center also, and each BSC typically controls up to several hundreds of BTS, that means base transceiver stations. So you can see that some base transceiver stations may be located at the BSCs. I mean, these are some of them are closely associated with BSCs, or some of them may remotely located and connected to the BSC by any kind of microwave link or leased line. So some kind of handoffs between two BTS, that means the two base transceiver stations under the control of the same BSCs, are handled by this BSC only, but not the MSC, because whenever we are going to establish any link between this mobile station and the mobile switching center, we need a third party intervention, which by this base transceiver station and the base switching center. Now what happens, that whenever these BTS, I mean these handoffs are handled between, handled by the BSCs, but not this MSCs. So this automatically, reduces the load and hence switching burden of this mobile switching center. And what this NSS, this network switching subsystem do, you can see that this mobile switching center appears as it is a heart of this, network switching subsystem. So this NSS manages the switching functions of the system, and it allows this particular MSCs to communicate with other networks such as PSTN or ISDN, or some kind of internet or data networks like this. And this NSS handles the switching of GSM calls between external networks and the customer databases also. And automatically what happens, that whenever it switches the calls between the external networks and the BSCs, then this is also responsible for managing and providing some external access to several customer database. And MSC being the central unit of NSS, since this is MSC is the central unit, so basically it controls the traffic of among all the BSCs, because it basically controls, it has the power to control how much amount of BTS can be accessed by some BSCs, and automatically how much amount of mobile stations can be accessed by BSC via this BTS. So basically this MSC has the power or has the authority to control all the traffic among these all BSCs. And there are, you can see in the picture that this MSC handles three different databases, different databases. One database is HLR, which is nothing but home location register. This is the second building block or second database is the VLR, that is visitor location register, and the third one is authentication center, which is AUC. So basically, and you can see that this particular MSC, this has a kind of operation support subsystem also, this OMC, this operation support subsystem also. This is a one kind of subsystem, and that basically we are going to coming to the one by one whenever we are going to discuss each building block or each database system in our later slides. Now,
Sure.
now coming to the network subsystem, that means this part, network subsystem. So for this network subsystem, as you can see, that this is basically all the sub-component, we can say that these sub-component must be included in the network subsystem. One is mobile switching center, just we have just seen from this diagram. Then there is home location register, then there is visitor location register, then there is authentication center, then equipment identity center, and obviously the gateway MSC. Now mobile switching center, what we are going to say, that is, so it is basically included in the GSM system, for call switching, what we have just, seen from the diagram. So its overall purpose is the same as that of any telephone exchange. So basically this has, a certain three major functions that every APC has to carry out. One is called processing, which includes control of obviously the data or the voice call setup, and obviously some kind of inter BSS or inter MSC handovers and control of mobility management. And there is some kind of operations and maintenance support also, which includes the database management, because this MSC is connected with, we have already seen that this MSC is connected with three different, major databases. One is HLR, then the second is VLR, then the third is AUC. So automatically it also it can handle, or it is also capable to handle all the database and traffic metering and measurement, and obviously a man machine interface, because this is a a kind of center of total process. The third functions which basically MSCs carry out, that is manages the interfaces between GSM network and PSTN. So I am coming to the radio interface, which basically GSM handles in our later slides. But before going to that, basically we need to understand that when the MSC provides the interface with the other networks in the GSM network, it is known as a gateway MSC. That is a one kind of point. So basically now coming to the different databases first. First the database which we are going to start with, that is HLR or home location register, the
Sure, sure.
first database. So basically, what is that database? This HLR database is nothing but, this is a kind of database which contains subscriber information. This contains subscriber ID, like subscriber ID, which I have just written here. So this contains subscriber information and location information for the users who reside in the same city, or you can say same service area of a single mobile switching center. So each GSM subscriber is assigned an international mobile subscriber identity, which is IMSI number, and we know that this particular number is unique for each user, and it is used to identify each home user. So basically what happens that whenever we have this kind of register, then we can automatically, by using this IMSI number, we can locate the subscriber. We can actually access the subscriber status, that whether this has subscriber is registered one or unregistered one, and automatically it can also send some kind of authentication key to the AUC authentication center. And obviously mobile subscriber roaming number is also maintained in this particular register. So this is all about what is the the home location register. Then if we can remember, our second database was the visitor location register. So this is all about visitor location register. As you can see that this visitor location register is a database usually which can temporarily store IMSI and customer information for each roaming subscriber who is visiting the coverage area of that particular MSC. That means this is a kind of visitor location area which can be an area under one single MSC, right? And you can see there is another visitor location area which can be the area under two or more than, I mean more than one, maybe two or three, maybe two and three, if you can see this area, three mobile switching centers. So whatever be the number of mobile switching centers, those mobile switching centers often maintain that particular visitor location register, so that it can also access the IMSI number and customer information, that is basically the also stored in the home location register, so that it can temporarily access and temporarily store those numbers for each roaming subscriber. That is why it is called visitor location. So the subscriber who is visiting, fine. So as a roaming subscriber, so basically all these data are stored in the VLR. Now the VLR is linked between several MSCs in some regions, right? And contains subscription information of every roaming user. Once a roaming, now imagine that there here you can see there are two MSC areas, right? So once a roaming mobile is logged in the VLR, that means the visitor location register, the MSC sends the necessary information to the visiting subscribers VLR, visiting subscribers VLR information to the visiting subscribers home location register, so that the calls to the roaming mobile unit can be appropriately routed over the public network, which we have just shown in the previous slide, that is the PSTN, by the roaming users HLR. That is why we are often saying that whenever you call me whenever I'm outside of my home location, then you are calling into my my home location number, but I am accessing that particular call from the visitor location and database region. So basically that is why this VLR is linked between several MSCs in a region, so that basically there are no such avoidance of transmitting some kind of information related to IMSI number or related to the roaming mobile number from area to area, if the particular subscriber is roaming between one area to another area. Every time that very necessary information to visiting subscribers HLR may be sent, so that calls to the roaming mobile unit can be appropriately routed over the PSTN by the roaming user's home location register. So this is the visitor location register which uses or which operates in this manner. Then the third database, which is the major database, is authentication center. Now there is a register which is the home location register. There is another register which is the visitor location register, and every time these two registers can access the informations from or to between these two registers, and can access and can temporarily store. But where does this authenticity lies? So basically what happens that in case of authentication center, sometimes it may happen. Okay, for one thing I want to mention, that I forgot to mention, that whenever we are saying this home location, about this home location center where the some kind of information is transmitted to the authentication center as well. So basically what we need to mean by that, that it provides some local database for the subscriber wherever they are physically located within a public local mobile network. This may or may not be the home system also. So it is a local database and contains a copy of most of the data stored in a home location register. So basically those are the information that home location register passes to the authentication center. So that is why it contains a some kind of mobile status, this subscriber status, which we are saying that registered or unregistered. And if it is registered, then whether this mobile status is busy or free or no answer or what is that. So basically that is what we are trying to say, that this home location register also transmits some kind of authentication key to this authentication center. So coming to this authentication center now, what happens that this is a kind of strongly protected database, and that can handle the authentication and encryption keys for every single subscriber in the home location register as well as in the visitor location register. So basically that a authentication center contains a register called equipment identity register. This is a kind of register, it basically stores, which helps identifying stolen or fraudulently altered phones that transmit identity data which do not match with information contained in either home location register or visitor location register. So in that way this authentication center can find out whether there is any kind fraud or anything else. So basically, and also, it ensures all the confidentiality of itself. So that is why this authentication process will usually take place each time the subscriber initializes on the system. So basically, authentication center or authentication process by the authentication center will start as soon as the subscriber initializes his or her call. The last thing which I need to mention is operation support subsystem. If we go back to the previous, this slide, you can see that here is that particular subsystem which I have told you to basically, to deal with in the later slide. So this operation support subsystem, you can see that this is also, in some manner, it is a kind of link between this MSC and OMC. So basically, what happened, this OMC is nothing but the operation maintenance centers. So basically, this OSS, operation support subsystem, or this particular subsystem supports this operation maintenance centers for, monitoring and maintaining the performance of each of the, mobile station, the base station, the BSC and the MSCs, everyone's. So everyone's performance is going to be monitored by this operation support subsystem, or you can say the operation maintenance centers. Now, what are those functions? Functions are the major functions are maintaining, obviously, telecommunication hardware, maintaining network operations, managing all mobile equipments, charging and billing procedures. So these are all the thrust areas where basically this operation support subsystem works. Now, coming to the radio subsystem or interfaces. Now, what happened in the previous slide, in the very previous slide, whenever we have discussed the the radio, the GSM architecture, we have already mentioned that we are going to deal with this radio subsystem or radio interfaces. That there are three kinds of, we can say, the interfaces. Those are very important interfaces which GSM service deals with. Those three surfaces, if you can see this particular figure, we can see that this is a kind of radio interfaces, or we can say GSM radio air interfaces also. This particular, the first interface, which is between the mobile station and the BTS. Then there is a second interface, which is called ABS interface, which is between BTS and BSCs, and obviously the third interface, which is the A interface. See, I have not completed this particular, diagram in the right hand side, because the right hand side is exactly same what we had in the GSM architecture slide. That means after BSCs, this BSC is connected with the MSC, and finally this MSC is connected with the public network or PSTN. So what happens, that this interface between this MS and BTS is the GSM radio air interface. The interface which connects BTS and BSCs is called ABS interface, which we have just told. And this interface carries traffic and maintenance data, this ABS interface. And you can see that these BSCs are physically, connected via the dedicated or lease line or microwave link to the MSCs. The third segment, which we had in the GSM architecture. And obviously the interface between BSC and MSC is called the A interface. So these three interfaces are the prime interfaces. Sometimes you can have 2 or 3 marks question about the radio interfaces. Between which and which the interfaces are situated, you have to answer correctly, or you can expect the 1 mark multiple choice questions from this particular radio interfaces. So that's all about today's class, because we have come to the end of the GSM architecture and GSM subsystems, and obviously the GSM services, GSM advantages. So I guess now, if you are given a kind of questions to write a short note on GSM or discuss about the GSM architecture, you will be capable to, answer all the questions properly. So now I'm going to, uh, start the video, and if you have any queries, you can ask me or related with today's class.
Ma'am, in the second slide, you told about handoff. Means,
Just a minute. Here,
ma'am, in the second slide, you told something about handoff. So my question was, what is handoff? I
oh,
even
so you didn't, attend the cellular concept. That handoff is some kind of, the process where basically some kind of, in case of cellular concept, what we have a number of cells, right? And each cell has a kind of base station over there. So basically what happens that whenever a particular subscriber or a particular mobile station is moving from one cell to another cell, what happens that in the whenever that mobile station is going, to is moving, farther from the particular base station of a particular cell, then it obviously, it usually loses the connection from this particular base station. And automatically what happens that whenever we are going to reach to the another cell which is having another base station, until and unless we are going to, enter to the strongest data connection or strongest the the network area, what the second base station of the second cell is offering, we are going to, some kind of voice cracking, some kind of, instability or in the instability in the call. The call may drop, and this kind of phenomenon we can, expect. So handoff is kind of process that, this is a kind of process which you can say that make before break. This is a kind of, thing that means handoff is kind of, process that it helps to achieve a strong, network provider by any base station, by the nearest base station, nearest substation, until, before the call is going to terminate. So basically, whenever the mobile station is a kind of mobile station is moving from one base station to another base station, so the second base station tries to, capture, or tries to give that particular mobile station its total signaling strength, so that this particularly, before the call drop, this particularly, the call is going to be switched into the next base station which is offered by the second cell. So this is a kind of, handoff. So basically this is a kind of, that is why one question usually come, that is, what is the difference between soft handoff and the hard handoff? Hard handoff means you can, you can, experience a kind of, switch over from one base station to another base station. That means you can experience a kind of, signaling strength, and some point of time you can have a kind of, changes, you can have a kind of, what can I say, that enhance of the power and enhance of the, voice quality, and you can experience that, yes, now basically that kind of, switching has already happened between one base station to another base station. This is a kind of hard handoff. And what is a soft handoff? Soft handoff, what I have just told, that usually every, now the mobile system is so, the improvised version ones. So basically they are all, utilizing the soft handoff. That means you have to make the call before break the call. That means before breaking the chain from the first base station, you have to make the connection with the second base station. So the transformation or the transition from one base station to another base station is so smooth that you cannot even, understand that your call is, gradually, changing from one base station to another base station while you are moving from one cell to another cell. So this is a kind of, handoff, and that is, best described in my previous lecture, which is the cellular concept, or cellular architecture in that particular PPT.
Ma'am, actually in that video, just mention was there of about handoff, not.
Okay. Okay. Then one thing we can do is, we can arrange one class in the next session, in the next day. That is the handover, this total handoff or handover strategies, how the particular handoff is going to be occurred, and how one call is going to be set up and call is going to be disconnected. Then I think it will be
Hmm.
clear for all of you, and that
Clear.
is one, major important area as well. So we can arrange one class in the next day, so on this particular topic first. Yes.
Okay.
Sure.
Okay. Yes, ma'am.
Okay.
It will be
Okay.
helpful.
So
Ma'am,
yes,
in
yes.
HLR,
Okay,
ma'am, in
I'm going
HLR,
to continue the question answer session, since there is a less than 1 minute is remaining. So everyone, all of you, just write down your name and roll number simultaneously in the chat box. Yes, Abhishek, tell me.
ma'am, in HLR, subscriber ID and location both are stored.
Yes, yes, yes.
Okay.
Because sometimes it may happen that whenever you are, suppose you are in now, you are now in visiting mode, you are as a roaming customer, roaming subscriber. So you are in the visitor location.